At this point in the course, you should be very familiar with pulling specific internal energy and specific enthalpy values from property tables. Well, we can pull entropy values from property tables in the same way as we do these other properties. Just a reminder, two independent intensive properties are needed to retrieve entropy data from tables. So if you have temperature and specific internal energy of steam, you can go and pull an entropy value. Or if you have a pressure and a specific volume, or pressure and an enthalpy, you can likewise pull entropy values from a table. Now is the time to introduce another type of diagram. In addition to PV and TV diagrams, we can also draw TS diagrams, which are equally useful. And just like PV and TV diagrams, TS diagrams also include a vapor dome or a vapor dome for at least substances that can be in multiple phases in our analyses. Of course, if you did a TS diagram for an ideal gas, you would not have a vapor dome. So just like those other diagrams, inside the vapor dome we have a two-phase mixture. To the right of the diagram, or to the right of the vapor dome, we have a superheated vapor. On the left-hand side, a compressed liquid, or a supercooled liquid. And at the top is our critical point. And we can also draw isobars on this diagram, and those look very similar to those isobars on TV diagrams. So this would be P equals a constant here. So higher pressure isobars are going to be higher in the vapor dome, lower pressure isobars are going to be lower in the vapor dome. And where this line of constant pressure meets the right-hand side of the dome is a saturated liquid, so nothing new there. And over here where it meets, this is a vapor, saturated vapor. And over here, saturated liquid. All right, so these diagrams are very useful for comparing ideal versus actual processes, so we can see increases in entropy for different processes. Okay, and because the vapor dome is set up the same way as TV and PV diagrams, we can define quality in terms of entropy. So this would be the entropy of our substance minus the entropy of a saturated liquid over the difference between the entropy of a saturated vapor and entropy of a saturated liquid. Now I've intended to put all the S's on this board as lowercase, but these can be done for uppercase as well. So of course, if we have extensive entropy values in here, our quality will still turn out the same. So just like we've done for other properties, we can use quality to find entropy. So here we have maybe SF plus X times SG minus SF. So we really do treat these in the same way as we do internal energy or enthalpy. For superheated vapors, S is, or entropy, is a function of temperature and pressure, as it is for two-phase mixtures as well. So that's unchanged from internal energy and enthalpy. For compressed liquids, as we've done before, we approximate values of entropy as that of a saturated liquid at the same temperature. So just as we have done for like internal energy, for example, and specific volume, we can approximate entropy as that of a saturated liquid at the same temperature. All right, so retrieving entropy data.